analysis that you are going to do, how many categorical variable involved. Okay, so for one-way ANOVA, you only consider one categorical variable, whereas for the two-way ANOVA, you have more than one categorical variable that you need to include in your analysis. And then there are two different ways on how we estimate the population variance, unlike the t-test. Okay, in the t-test, you will measure or compute the variability of observation within the group using Amanda, how did you measure the variability amongst the observation in your t-test? Amanda, unmute yourself.
Yes, Doctor.
How are you going to measure the variability between the observation when you perform two t-tests?
Sorry, Doctor, I don't know.
From what? How are you going to measure the variability between the observations for t-tests? Adriana? Adriana? Okay, you use chat, Adriana. No, there's no chat. Adriana, unmute yourself. If not, you can use the chat. Adriana? Oh, Adriana tak ada ke? Ashraf? Ya, Ashraf. Saya tak dengar jawapan kamu. Saya dengar doktor je.
Can you repeat again, Doctor? The question.
Repeat again. Siapa yang suruh saya repeat tu saya tahu tu. Kamu daripada mana-mana. Kamu berlari ke daripada bilik sebelah? Macam mana kamu measure?
From toilet.
How did you measure the variability between the observation for t-test? If you want to perform the t-test. Boleh, Ashraf? Hey, Daniel?
Forgot.
Kamu tak baca nota saya bagi ke? Daniel Lim Jin Yi.
Ya, Doktor.
Yeah. How did you measure the variability?
Define known and alternative hypothesis.
No, that is the statement for what you believe. I ask you, how did you measure the variability of your observation when you perform t-test? Look at the notes. Everyone.
Compare the mean and standard deviation.
Well, no. The answer is partially correct. Mean, you cannot measure the variability. The exact answer is by computing the standard deviation or variance. Okay, Daniel? Okay, not mean. Mean if you want to measure the central tendency, central tendency of your data. So in ANOVA, the approach of estimating the variability between the observation is slightly different. Okay, they are not using the standard deviation, unlike the t-test. In ANOVA, what you are going to measure is the variability between groups variance within group variance. So there are two types of variability, between group variance and within group variance. So whereas in a t-test, you are measuring the standard deviation or the variance within the group only. Okay, within the group only. And then you compare it. But in ANOVA, you measure the variance within the group and between the group, and you compare it both. Okay, right. So the test statistic. What is the test statistic for the t-test? Dora, Debra. Dora, what is the what is the statistic that you use in t-test? Dora? Are you sure that I already taught you about t-test? Macam tak ramai yang tak dapat jawab ni.
Doktor,
Ya,
yang hypothesis testing.
kan. Apakah statistik yang kamu gunakan semasa kamu buat ujian T? Apa dia statistik ujian kamu?
Zero.
Itu kalau kamu nak tag, itu nama ujian bagi normality.
I think I forgot, doktor.
Forgot. Rasanya bukan forgot ni, kamu tak terfikir. Okay. Ironica Benedict. Ya, Ironica. Saya tak dengar suara kamu. Ironica. We can't hear your voice. I can see that you unmute yourself, but we can't hear your voice. Guna chat lah, Ironica. Saya nak tahu jawapan kamu. Use the chat. PET test? No, that is the type of the test. Are you Rashida? Are you Rashida? Ayu Rashida tak ada. Kita tanya pula Karen Tifa. Mana pergi Ayu Rashida ni?
If the statistic, doctor.
Apa ulang balik Ayu?
This is Karen.
Oh, sorry, Karen. Okay. Alright, thank you, Karen. Right.
Okay.
That is the correct answer. The test statistic for t-test is T statistic. So in ANOVA, we use F ratio statistic. F statistic. Okay. So this is the test statistic for the ANOVA. Okay. And then this is the how to get the F ratio, the mean square of the variability for the treatment divided by the mean square of error. All these two came from this one. Okay, you need to measure the between groups variance and within group variance to get your F ratio. Okay, I will show you the formula later. Right? Whereas for the t-test, you use T statistic. Okay, so the T statistic is T equal to mean, the mu, over standard error. Okay, the standard error is standard deviation divided by the square root of n. Okay, So if you still remember, okay, standard error is mean standard error, the square root of the standard error, sorry. Macam mana letak square root? Tak boleh pakai. Okay. The square root of the standard error. The square root of the variance, sorry. So as a sigma, okay, let me put it here like this. Divide by sigma over, the sigma is the standard deviation, okay, over square root of n. SQ RT n. Okay, so that is the T statistic. Yeah. So now let's have a look at one way ANOVA first. As I mentioned just now, one way ANOVA, when we want to compare a few samples. A few sample meanings that you need to have 2 or more, or maybe more than 2. So some of the people say, hey, why did you use ANOVA for 2 samples? We can. It's just that in normal practice, we choose ANOVA when we have more than 2 samples. All right. So if the sample size if you have only 2 samples and then the sample size is considered as has a huge difference, let's say the number of size for the second sample is double or triple from the first sample, then we would like to suggest you to use ANOVA instead of t-test. Okay, because of the sample size gives some impact on the estimates of the statistics. But if there is not much different in terms of the sample size between the 2 samples, then you can proceed with the independent t-test, independent samples t-test. Now, for one-way ANOVA, one independent variable which has a number of different levels. So when it says that a number of different levels, it means that they have different groups. Okay, different levels mean different groups, and the different groups actually serve as different samples. So you measure one thing, concentration, maybe temperature, and then you have different levels of conditions. Okay, so these different levels of conditions serve as the different groups or different samples. So these levels correspond to the different groups of condition. For example, when you are comparing the effectiveness of 3 different teaching styles on students' math score. So you give a diagnostic test to your students, right? And then you will get their math score or bio score, whatever, all right, related to your programs. And then maybe there are 3 different teaching styles from 3 different lecturers. Okay, so since that you have 3 groups, then you cannot use t-test. You need to opt for ANOVA, one-way ANOVA. Why one-way ANOVA? Because you only have one categorical variable, which is different teaching style or teaching styles. Okay, so and then the second example is if you want to compare the effectiveness of 4 different types of painkiller to relieve muscle pain. So the measurement, the variables that you measured is, in this case, I consider the time in minutes, maybe. In minutes on how long the painkiller can relieve you from the muscle pain. Okay, and then you actually try 4 different types of painkiller. So you try the first one, and then you measure how long it will take for you to feel that the pain is gone, right? And then maybe we give you a period of time, okay, ample period of time to flush out the effect of the first painkiller, And then when you have the muscle pain again, we give you the second type of painkiller. And then flush out, and then when it happen again, we give you the third painkiller, right? And then every time you are given a new painkiller, you will measure how minutes, how much, okay, the time for you to relieve the painkiller can relieve your muscle pain, right? So in this case, we only have one dependent variables, meaning that something that you, a variable that you can measure in scale, all right? And then you have another variable in categorical, which is the types of painkiller. In this case, you have 4 levels because you have 4 different types of painkiller. So it means that you have 4 groups or 4 samples, right? So these 2 examples on how you need to choose one-way ANOVA. Okay, but then you cannot simply choose one-way ANOVA, because prior to the analysis, you need to make sure that certain assumptions, okay, has been fulfilled, or they are not violated, right? Because if they do, then the result of the analysis will be questionable, unjustifiable, or less accurate, right? Not precise. So you need to make sure that the assumptions has been fulfilled. The first of all is the population normality. For each group, yeah, this is how you do your normality test for independent test. Remember, because you, let's say for the BMI, in your case before, if I want to measure the normality, the distributions of the BMI, I will choose BMI without comparing between groups. But then if I want to perform independent t-test, let's say to compare the BMI between gender of my students, female and male, then I need to perform the normality test according to the gender. So I need to split my BMI data into 2 groups, females BMI and males BMI. And then both of the data, the subset of the data, must follow normal distribution in order for me to proceed with the independent t-test. Okay, PAT t-test. Okay, who is? Okay, now, so in this case, the same concepts applies. Okay, so I need to split the let's say from the previous example, the score, the mathematics score, into 3 different teaching styles. So I need to assess the normality of the math score according to the teaching style, or with respect to teaching style. And then the second example, I need to assess the distributions of the time to relieve muscle pain with respect to 4 different types of painkiller. If all the normality tests for all of the groups follow normal distribution, then I can proceed with my ANOVA after the second assumption fulfilled. So there are 2 assumptions there. The second assumption is the homogeneity of variance. So the assumptions are the same assumption when you perform independent t-test. Okay. In the second assumption, we must make sure that each group has similar variance. So in one-way ANOVA, the same test also included in the default setting, not default, the independent test default, but for the ANOVA you need to tick, okay, the option for the 11 tests in the dialog box. I will show you later. And then here the 11 tests not testing the variance like independent test. The 11 tests in this case will test the sum square of treatment, error, and total, and so forth. Okay, right. So there are a few terms that you need to be familiar with. The first one is SS stand for sum square of. Okay, sum square means that you need to square something, right? The sum square here means the sum square of the variability or the variance between treatment. And then this one, the error, sum square of error. And this one is the sum square of total. Okay, and then from the sum square, we will get the mean square. The mean square of treatment and the mean square of error, because we need these two to compute our F statistics. Okay, remember just now our F statistic is mean square treatment over mean square of error. Now, this is how we write our hypothesis statement. So this one not mu1 but mu subscript 1, okay? And then in null hypothesis, we always assume that everything's are more or less the same. Okay, for the alternative hypothesis, you cannot write mu1 not equal to mu2, not equal to mu k, something like that. It is wrong. Okay, in alternative hypothesis, you need to say that not all the population means are equal, or in other way, you can say that at least one of the population means are different from the others. Or, okay, other words is HA, at least one of the population mean is one of the population means is different. Okay? As long as you get, even though only one of the population means different from the others, you can already reject your null hypothesis statement. Okay? So you don't need to have every means different from each other. No, you don't have to. It is sufficient if you have only one of the population means differ from the others. So the decision rules is you reject the null hypothesis if the statistic F, which is can be obtained from mean square of treatment over mean square of error, greater than the F critical value. So when I said F critical value, you need to get the value from the F probability table. Okay, this is F critical value from the F probability distribution table. So for the F critical value, you can get it based on 2 degrees of freedoms. Okay, the first degree of freedom is the degree of freedoms for the numerator, and the second degree of freedom is the degree of freedom for the denominator. So this is the degree of freedom for treatment. So if you have K treatment, means that degree of freedom is equal to K minus 1. And then this is the degree of freedom for error. So if you have the total number of observation regardless of the treatment is n, and then k is the number of treatment, so n minus k will be the degree of freedom for the error. Okay, any questions so far? If it's good, if so far is if it's good, no questions, then give me thumbs up. If you have any questions, please send it in the chat. Okay, so far so good, huh? Okay, we move on to the next slide. Okay, this is the standard format for the one-way ANOVA. We have treatments, we have errors, and we have total. So these are the three sources of variation: from the treatments, from the error, and the summation of both give you the total. Okay? From the treatment means that between the treatments, error within the treatment, regardless of the treatment. Okay? Between the observation and the grand mean. Grand mean means that the average of all the observation regardless of the treatment. Okay, the first information that you need to know is the degree of freedom for each source of variation. So the degree of freedom for the source of variation treatment is k minus 1 if k is the number of treatments or levels or group. Okay, and then let's say n is the number of observation. And k in bracket n minus 1 is the degree of freedom for the error. And the total is kn minus 1. This is the degree of freedom for total. Okay. And then the sum of squares, you need to get the sum of square for treatment, sum square of error, and then you will get the summation of both, you get the sum square of total. So we need this one divided by this one to get the mean square of treatment. Okay. And the sum square of error divided by kn minus 1, the degree of freedoms of the error, to get mean square of error. And then after you obtain your mean square, then you need to divide mean square of treatment, okay, with mean square of error to get your F statistics. And this F statistic will be compared against the F critical value from the F probability distribution using the degree of freedoms from the numerator and the denominator. Okay. So if the F statistics is greater than F critical value, then we have sufficient evidence to reject our null hypothesis statement. Okay, any questions so far? Thumbs up if you don't. If you have, then just ask away on chat. Any questions? Okay, Noah. Okay, next slide. What's that? Okay, this is how we compute our sum square and mean square. Okay. We have sum square for each of the observation, sum square of error, sum square of treatment, sorry, total, and sum square of treatment. So to get the sum square of total, we only have to find the sum square of treatment and sum square of error. Okay, so you don't have to find all these three, because if you get any of the two, then you can complete this equation, right? So choose either you want to find this one and this one, or you want to find the 2 and the 3. Okay, so it's up to you. Okay, you can choose which one that you feel you can get the answer faster, okay, and less confusing. But I will explain every single one of them, then you will decide, okay, which one that you feel easier to compute. Okay, now for the sum square here, okay, we have j equal to 1 until ni. So let's say we take the example of the painkillers just now. Okay, let's say for the example for the painkiller, we have K equal to berapa? K, kita tanya Ryan Benjamin, adakah?
Ada, dokter.
Berapa K kamu? Daripada example painkiller tadi. Kamu ada ke waktu saya explain tentang painkiller tadi, Ryan?
Ada.
Ada kan? Okey. Saya tunjuk balik. Berapa?
4.
4. Okay, good. Thank you. So the K is 4. Okay. Now, let's say if I assume that the number of muscle pain patients for each for the groups, the subgroup is 5. Okay, so the N is equal to 5. Okay, say K equal to 4. Okay, so I referring to the group. So I equal to 1, 2, 3, 4. I'm sorry, no. Yeah, group I means that group 1 or group 2 or group 3 or group 4. Okay. Right, so in this case, K equal to 4. Now, why I need to define all this value, because to make sure that you are not confused when you do the calculation. Okay. Now, for the SSI, this is where when you try to find the deviation for each of the variable from the mean of the group. Okay, so if you can see here j equal to 1 until ni. This one I use ni because mainly the number of the patient for the painkiller for one type of painkiller might be different. Okay, so it depends on ni. Okay, maybe N1 is equal to 5 people, maybe N2 10 people, something like that. So I use ni. So xij minus xi bar, I am referring to the group where it belongs. J referring to the number of observations within the group. Okay. So J equal to 1 until ni. So if all of the group have different same number of patients, then I will be 5. Okay. So J equal to 1 until 5. Okay. Now, the sum square of error is when you sum up all the variability limit deviation squared of all the treatment. Okay. This one you want to measure the variability within the group. Okay. And then you sum up everything, then you get the measurement of the sum square of error. Whereas for the sum square of treatment, you will find the square deviation of each of the variable from the grand mean. Okay, from the grand mean. So you can see that here, the X bar without the subscript. Okay, this one with subscript meaning that this is the mean for each group. This one mean for all of the observation. Okay, so this is how you get the sum square of total And then for some period of treatment, you try to find the deviation from the mean of group to the mean of every of all the observation, regardless of the group. So you square it. And then times with the number of observations. If you have n equals 5, it means the same for all of the group, then it will become 5 from here. Okay. So this is the sum square of treatment. So the first group, the mean of the first group minus the grand mean, and then you square it, plus the mean of the second group minus the grand mean square, plus and so forth. Okay, then you will get this one. Okay. What thing about ANOVA is ANOVA can detect significant difference between, but ANOVA cannot pinpoint where the significant difference came from. Okay. What caused the significant difference? Right. So normally for the way ANOVA or any ANOVA test, we have a complementary or what do you call it? Expanded test. Okay. To identify the cause of the significant difference. So the test is called post-hoc analysis. Okay. Or sometimes it is called multiple comparison analysis. Okay. So another name for the post-hoc analysis is multiple comparison analysis. So it will test the entire set of comparisons done by us. Done by us. Right? So normally we do multiple comparison, let's say multiple t-tests, it will definitely increase type 1 error. Okay, because the first comparison you have 5% one error. And then the second also another 5%. The third comparison also carries 5%. Yeah. Type 1 error. The probability of committing type 1 error. So it's becoming more and more. Right? So it will increase the risk. It will increase the risk. So that is the reason why we have post-hoc tests, because post-hoc tests can actually control the risk of type 1 error. Okay, it can control the risk of type 1 error. Now, the more option test offers, the stricter will be the determination of the significance. Okay. So overall, you don't have to worry, you don't need to do anything to the level of significance or the alpha. Okay. So in this case, called alpha as nominal alpha. Okay. So Sharp, and Duncan and other post-hoc analysis has been formulated in such a way that it will control the risk of type 1 error. Okay, let's look at one example. Let's say you have 3 different detergents, and then you want to compare the whiteness rate between the 3 detergents. Let's say you are given 15 swatches of white cloth, which will first soil with Indian ink. Okay, and then wash in an agitated type machine with the respective detergents. So we have detergent A, we have detergent B, and we have detergent C. So you need to test the mean difference under 1% significant level. Normally we use 5%. This time I try to change to 1% and make it stricter. Okay. So now I would like to ask daya hawa is yang ni. Daya what is your K here? What is the value of your K daya hawa? Daya hawa. K tak ada. Lambat kamu jawab. Apa K kamu? 15. Para Zulaika betul 15. Para Zulaika tidak ada. Iya, betul. So, daya yang salah. Ya. Okay, cuba masuk ke dulu. Masuk ke dulu. Keadaan atau tadi. Okay, jawapan 3. Because we have 3 types of detergent, so K is 3. Now, what? Let's say the K is 3. Okay. And then K is 1. Katakan I, let's say I is 1, 2, and 3. Okay. So kita ada what is the and 1 and 2 and 1, 2, 3 itu adalah subscript here in Microsoft Edge. Alright, so what is N1? Iqbal. Okay, good. 5. Kasmariana N berapa gandanya? Kasmariana tidur ada Kasmariana tidur ataupun tak ada di depan komputer. Ya, ada. Okey, berapa? N2 berapa? 5. Okay, thank you. Siapa yang jawab saya akan tidur. Jangan salah saya kenapa kamu tak nak kalau kamu tak nak bagi saya kamu tidur buka kami. Saya boleh nampak kamu. Okey, nanti N3 berapa nilai N3? Fatihah. Tak ada masalah Fatihah. Fatihah 5. Okay, good. So, how do we know 5 kira ialah berapa? Basically ada di sini 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, it seems like all of the detergent has different numbers of specimen of white cloth, right? Now, macam mana kita nak buat? Kalau saya punya formula, if I use the formula given here, slide 8, I will gather these values for my Anova table. So, what I want to do is try to use or try to apply this formula to get these values. I think you learned already in your environmental statistics kan? Ya, yang belajar kan? Saya tak tahu yang ajar sama dengan male ataupun perempuan. Okay, so from you can actually measure this one. Maybe they use slightly different formula. In this case, I want to use the sum square of the sum square formula. Okay, because it is more accurate compared to the other formula. Now, so we have, since that we have treatment, the number of treatment, the K is 3, so the degree of freedom will be 2 because 3 minus 1 is 2. And then for the error, I still remember the formula of the error is K minus 1. Okay. Alright, so K minus 1 is, sorry, K minus 1. Yeah, they're wrong. Okay, so we can see from here K minus 1. Alright, so K and minus 1 means that K times 3. Okay, so 4, sorry. And minus 1. So K minus 1 is 12. Right? And then we have 14 here for the total. Okay. Which is K minus 1. Right. So from the sum square of error, so you need to practice on how to get this value. Right? Okay, you need to get these two values manually. Okay. Just to so that you can strengthen your understanding. Now, and then this value divided by 2, you get 195, and 276 divided by 12, you will get 23. And then 195 divided by 23, you get 8.48. Okay, and then you need to compare with the statistic value. Okay. With alpha is 0.01 and degree of freedom is 2 and 12 from the F probability distribution table. Compare this value with 8.48. Okay, you need to compare F statistic, which is at the F statistic, which is 8.48 against the F critical value from the table. Then you will know whether you should reject or shouldn't reject the null hypothesis statement. So the F statistic from the table is 6.93, okay, meaning that the F statistic is greater than the F critical value. So if it's greater than the F critical value, so if you know that the F probability distribution is slightly skewed, so let's say this is the F critical. Okay, F critical, that F statistic will be a bit far to the right. So this is the p-value. Okay, the area under the curve for F statistic, 8.48. Okay, so it is in the rejection region. So since F equal to 8.48 exceeds 6.93, the null hypothesis must be rejected because we have sufficient statistical evidence. And we conclude that the 3 detergents are not all equally effective in terms of the whiteness readings. Okay? So, but then if we can say that they are not equally effective, it doesn't serve the purpose, isn't it? Because we need the conclusion to be more informative. So to make the analysis result to be more effective, we need to perform the post hoc multiple comparison in order for us to find out which detergent is the best in terms of the whiteness readings. Yeah, so if the whiteness reading is higher, it means that the detergent is more effective. Okay, it's more effective. Now, this is the way on how we can perform the analysis using statistical package. What you need to do is you need to go to analyze, compare means, and scroll down, look at the last one. It says one-way ANOVA. Before that, of course, you need to key in your data, and the way you key in your data is similar to the way that you key in the data for the independent samples t-test. Okay, so in independent sample t-test, you need to have one column for the categories. This one is for categories, or the categorical variable, or the factor. All right, and another column for the readings, anything that measurable in scale. So you will get this dialog box, okay, this dialog box, and then you can see that the list of the variables, you need to transfer the whiteness reading into dependent list and the detergent into factor list, become like this. Okay, and then you need to click the option buttons. Why is that? I don't know what happened. Okay, the option button is this one. Okay, why you need to go to the option button? Because we need to test the homogeneity of variance. So this is where the level test is. Okay, so in independent sample t-test, you don't need to tick anything for the level test because it's already embedded together with the independent t-test. But for the ANOVA, you need to ask for it. So you need to go to options and tick homogeneity of variance test. And then I also tick descriptive here, just to see the difference in means and standard deviation, as well as the standard error between the detergent, between the whiteness reading from for different type of detergent. And then I will go to the button post hoc. Which one? This one. Okay. And then for the button post hoc, there are a lot of options there. So this one is the option for the multiple comparison test if the variants are equal. If the variants are not equal, then you need to choose either one of these four options. This is for the variance not assumed. Okay, so remember that. Bukan semuanya boleh guna Turkey, ya, ataupun Duncan or Banfarani, ya. So it depends on whether their variances are equal or not. Now, for the equal variances assumed, there are also different rules. Okay, for example, for the Bonferroni and Duncan, okay, you can only choose these two if your observations, the number of observations for each treatments are equal. Macam tadi lah, yeah, we have all the treatments have 5 observation. But if they are not, then you cannot use Bonferroni or Duncan. Okay, you cannot choose this. You need to choose other type of multiple comparison. All right. So for the significant levels, the default setting is 0.05. So here I change it to 0.01. Okay, default setting is 0.05. So I change it to 0.01 according to the questions given to me. Okay, so this is the first output. We have detergent A. Once you click OK, then there will be output few tables. This is detergent A, B, and C. Okay, and the sample size is 5. And these give you the mean and the standard deviation. Okay, and then this is the confidence interval of the mean. Right. So here we have, we can see that the lowest whiteness reading belong to detergent B and the highest is detergent C. Okay. And then the standard deviations of detergent B is bigger compared to the other two detergents. So that's how you comment. When I ask for comment the result of the descriptive analysis, you shouldn't report all the values because the values I can read it. I want you to comment. So in terms of mean, you can comment which one is the highest, the lowest, and in terms of standard deviation, which one has the lower distribution, dispersion, and which one has the higher dispersion. Okay, you need to summarize it, not reporting the values, but summarize the values. Okay, summarize the report. Now, the second table will be the test of homogeneity of variances. Okay, so we can see that the p-value of the 11 test is 0.407. Okay, so when it's greater than 5%, it means that all the variances are homogeneous or more or less similar. And then you can see the ANOVA table here. So can you see the value? They are the same, okay, in the manual calculation, right? And then this one is the F statistics. And then from this F statistic, we can get the p-value. This is the p-value. This is the area under the curve for statistic F 8.478. So kalau just to make sure that you really understand the concept of the p-value, let's say we have the F distribution here, and then let's say this one is the F critical. Okay, F critical, right? Which is 6 point something just now. Let's see, F critical point sama juga dengan 6 point something. 6.48 ke? Saya tak ingat. 6 point something lah. Let's say 6.4. And then we have katakan X statistik adalah di sini. Okay. This one adalah X statistik, which is 8.48. Okay. And then the 0.005 is the shaded area. Okay, this is your p-value. The shaded area represent your p-value. Okay, but from this point onwards, the area under the curve is 0.01. Okay, but for the shaded area, okay, the value is 0.005. Faham ke? Thumbs up kalau faham. Okay, thank you. Now, since that there is a significant difference between the detergent, then I need to find which detergent is the best, which detergent is the worst one. Okay. So from here, we can see that this is a multiple comparison. I choose the key HSD. What you need to look at is the significant values here. And then you need to check which one is significant. Okay, let's try. So, what is the alpha of our test? Arif, Muhammad Arif? What is our alpha, Arif? Muhammad Arif. Okay, Muhammad Arif tidur. Muhammad Aiman.
0.01.
Yes, very good. 0.01. You boleh tahu daripada sini. It says 99%. Okay. So 1% is equal to 0.01. So based on the p-value from the multiple comparison. Okay, Muhammad Nakridin. Cuba tengok mana satu yang signifikan. Saya besarkan kalau kamu tahu mata tak nampak. Muhammad Nakridin. Muhammad Nakridin. Oh, dia sama juga dengan Arif, tidur. Kita minta Nur Mizatul Akma. Mizatul Akma. Oh, saya kena take note lah. Siapa-siapa yang tidur ni. Last call, Mizatul Akma. Tidur juga Mizatul Akma. Nakridin, Mizatul Akma. Dengan Muhammad Arif pun tidur tadi kan? Muhammad Arif, Mizatul. Okay. Kita tengok pula Nur Faiza. Faiza. Nur Faiza. Last call, Nur Faiza. Okay, Nur Faiza pun tidur juga. Faiza. Ramainya yang tidur ni. Kita tanya pula Nurul Fadilah Amirah.
Doktor Faiza daripada kat chat.
Dekat chat. Okay, Faiza ya. Okay, saya tengok chat. Faiza jawab. Tak dapat on mic. On, okey lah, tak dapat. Tapi jawab soalan saya tu. Apa soalan saya, Faiza? Cuba tengok multiple comparison. Mana agaknya yang significant different? Tengok, tadi baru je kawan kamu cakap. Alpha adalah 0.01. Sabrina? Okey, Faiza cakap deterjen B dengan C. Okey, betul Faiza, tahniah. Ha? Deterjen B dengan C yang significantly differ. Okay, in terms of whiteness reading. So, what happened to 0.029? This one is considered not significant at 1%. At alpha 1%, detergent A and B is considered not significantly differ in terms of the whiteness reading because 0.029 is greater than 0.01. Okay? So in this case, that's Turkey HSD gave you the homogeneous subset. Means that they actually group the multiple comparison result here. Okay. into groups here. So B and C, this is B, this is C. You know that, so we can say that the whiteness reading for detergent C is significantly higher compared to the whiteness reading of detergent B. Significantly higher. Whereas for detergent A, it does not differ to both of them. B or C. Okay, yang berbeza adalah detergent B dengan C. Okay, I give you one situation here. Let's say you adalah owner of laundry company. And then you need to buy in bulk the detergent for your laundry franchise, for example. And then detergent A, let's say the price per kilo is RM10 ringgit per kilo. Okay? For example. Example je ni. Detergent B is equal to RM10 juga. Detergent C also 10 ringgit per kilo. So sama je harga dia. So antara detergent, so you punya motto of your service adalah you menyediakan quality services. Okay? Quality services. Okay? Ataupun maybe you boleh tulis you punya motto dekat depan kedai kamu tu. Quality is our priority. Let's say lah. Now, you need to make a decision whether to buy detergent A, B, and C. Okay? So everybody ready dekat chat? Now, everyone, tell me which detergent that you will buy in order for you to maintain a good quality, maintain a good quality services, but at the same time, you need to get a good profit. Maintain a good quality and good profit. Okay, on chat. Saya nak tahu siapa yang beli A, B dengan C. Now, I give you 30 seconds. Okay, 10 second lagi. C daripada Arman. Arman paling cepat. C dia kata. Lepas tu Suji E second cepat. C. Alia pun C. Sampai ke Siti Nur Atira C. Okay. Siti Mah. Guru Wak. Siapa ni? Okay. C juga. Ada lagi jawapan? Itu jawapan kamu? Ada lagi yang tertinggal? C plus ni tak sampai pun 60 lebih jawapan, maknanya berapa orang? Okey, kejap. Saya nak snapshot dahulu siapa yang jawab. Maknanya yang tak jawab tu tidur. Sekejap saya save dulu jawapan. Saya tengok siapa yang jawab. Siapa yang tak jawab tu maknanya dia punya Webex saja on. Orangnya tak on. Okey. Saya ambil saya print screen dahulu. Okey. Lagi satu. Print screen. Yang paling seronok je bila saya habis lecture kan, saya selalu lambat keluar. Saya nak tengok siapa lagi yang tertinggal dalam Webex atau Google Meet saya yang tak keluar-keluar. Maknanya memang daripada awal lagi dia tak ada depan komputer. Betul ni, tak ada siapa yang mau menukar jawapan. Confident ya? Memang C ya? Adakah majoriti bermakna betul? Adakah jawapan daripada majoriti selalunya benar? Apa komen anda? Okey. Wih, sampai ke sudah semua C. Baguslah student biotek ni. Jawab laju semua. Dan semuanya sepakat. Tak ada perbezaan. Semua C. Okey. Kalaulah saya katakan, what is the best decision in terms of economics, right? In terms of economics, too many overlapping. Oh, patutlah. Sebab saya buka yang ni ya. Okey. Kalau in terms of economic, to maintain a good, awak baca betul-betul. To maintain a good quality and good profit. Jawapannya adalah C itu adalah salah. Kenapa agaknya? Ada yang mau yang bertukar fikiran. Kenapa saya kata salah? You can unmute yourself. You can use the chat. Kenapa saya kata salah? Sebab memanglah deterjen C ini mempunyai whiteness reading yang tertinggi. Okay, it's true. But then, yeah, it's tertinggi. So, kalaulah dia punya harga sama, maka jawapan C itu betul. Okay. Kalau harga dia sama, so I gave you all the values similar, right? So, good quality and good profit memang jawapan C lah. Ya, betul. Semua bagus. Semuanya sekata. Right? Because it has the highest whiteness reading. Right? Tetapi, katakanlah kalau saya change the price to, let's say, the price for, let's say, egg is detergent A is 8 ringgit let's say detergent B is 7 ringgit and detergent C is 9 ringgit. Okay, now mana satu yang the best detergent, everyone? Yang patut kamu beli supaya kamu dapat a good quality, but at the same time you can get a good profit. Okay, baru berbeza-beza sikit jawapan. Ada yang jawab A, ada yang jawab B. Tak ada yang jawab C. Masih lagi coming in. B, A, B, A. Okay. The answer is, okay, ada lagi. Okay, Daniel boleh nak jawab. Okay. A. Okay, nasib baik Daniel. Paling lambat tapi masih lagi jawapannya adalah betul. The right answer is A. Yeah, I know for those who answer B, because you see that the price is you jawab A. Those yang jawab B, siapa yang kejap saya salah apa? A, B. Okay. So, jawapan dia adalah A. Ya. Memang yang jawab B tu for detergent B is significantly lower than detergent C. So if you choose to buy B, even though you will get a good profit because the cost of the detergent is lower, but you cannot fulfill your vision yang pertama, which is good quality. Good quality for your customer, good profit for your company. Kan? Tak boleh. Yeah. And then why I cannot choose detergent C? Because definitely you can see from here, detergent C has the most expensive price per kilogram. Right? So it won't give you good profit even though it gives you good quality. I want both. Good quality as well as good profit. So the right answer is A, because even though the whiteness reading is lower than the whiteness reading when you use detergent C, but the difference of the whiteness reading between detergent A and C are not significantly differ. It means that walaupun bacaan whiteness reading itu adalah lebih rendah, but let's say if you look at by orang kata dengan mata kasar, there is no difference in terms of whiteness. You cannot tell the difference. The instrument, the machine can tell the difference, but you as a human, kalau you tengok, you cannot see the difference. Yeah, more or less similar. Nampak tak? So since that detergent A and C has no significantly differ in terms of the whiteness reading, and yet detergent A give you lower costs in terms of the detergent, the price of the detergent per kilo, then the best decision is to go for or to buy detergent A for all of the laundry franchise. Yeah, it will give you good quality to ensure a good quality service to your customers, as well as it will give you a good profit because the price is lower. Faham ke tidak? Kalau faham, bagi saya thumbs up. Kalau tak faham, you can argue on the chat. I will explain again. Okay, so that's it. So I don't think I want to finish the slide. I want you to read the two-way ANOVA, okay, yourself, right? That is your homework. If you understand the one-way ANOVA, so it's not that difficult for you to study the two-way ANOVA, but I will discuss it a bit after the your minggu bertenang. Okay? After your minggu bertenang. So if you have any question, you can ask me now. Any questions? Saya share balik attendance to those yang belum lagi scan attendance. Sementara tu yang lain boleh bertanya soalan. Ada soalan? Saya chat. Saya tengok chat ya kalau ada yang nak bertanya. Ataupun you can unmute yourself. Tak ada. Thank you, Fatihah. How about the others?
Doktor, saya punya
Ya.
kehadiran belum.
Sorry?
Saya punya kehadiran belum juga.
Vanisha ya?
Iya,
Vanisha ke?
iya.
Okay. Lepas ni Vanisha, kita tunggu grup ni dulu. Okay. Kalau tiada, that's it. Saya jumpa kamu tahun depan. Ya?
Okay.
Again, please